Hello, welcome to this session on planetary boundaries. Today we'll discuss what planetary boundaries are, why they matter, and lay the seed for understanding how renewable energy technologies and circular economy principles can help us operate within these limits. So, what are planetary boundaries? The concept of planetary boundaries was first proposed in 2009 by a group of 28 scientists. This framework identifies 9 critical Earth system processes that regulate the planet's stability. Staying within these boundaries ensures a safe operating space for humanity. Let's look at these processes. Climate change, introduction of novel entities like chemical pollution and microplastics, stratospheric ozone depletion, increasing atmospheric aerosol loading, ocean acidification, modification of biochemical flows, freshwater change, land system change, and change in biodiversity integrity. Each boundary is interlinked. For instance, deforestation affects both biodiversity and climate change. As a reference, it's important to know that in 1980, a few decades ago, none of these boundaries have been exceeded. Where are we now? Research shows that we have already exceeded 7 of the 9 boundaries. Currently, only 2 of the 9 planetary boundaries remain in the so-called safe operating space, highlighted in green, meaning that those areas of the Earth systems are in a state which allows humanity to develop and thrive for generations to come. It includes stable conditions similar to the start of the Holocene epoch about 12,000 years ago, which have enabled humans to develop agriculture and modern civilization. The ozone layer protects the Earth from harmful ultraviolet radiation. A stratospheric ozone above 277 Dobson units, as is currently the case, means that we are in a safe operating space for ozone depletion. Atmospheric aerosol loading describes the concentration of small particles influenced both from natural processes such as volcanic eruptions or human activities such as burning fossil fuels. Aerosols influence both cloud formation and the way irradiation passes through the atmosphere. An aerosol optical path depth below 0.1 is considered in the safe operating space. In the zone of increasing risk, highlighted in yellow to orange, there is a chance of destabilizing key Earth system processes and disrupting life support functions. The land system change boundary was crossed when less than 75% of the original forest area on our planet remained. Blue water stands for water in rivers, lakes, and groundwater, while green water refers to the moisture available to plants. The planetary boundary for freshwater change was crossed when roughly 13% of the ice-free land area of those streams experienced strong wet or dry deviations. Ocean acidification occurs due to the absorption of CO2 by the ocean, which reduces aragonite and lowers the pH value, making it harder for organisms such as corals to survive. This boundary was crossed when the aragonite saturation state fell below 2.86, which is 20% below the pre-industrial value. The high-risk zone, highlighted in red to purple, in there is a strong chance of irreversible damage to key planetary functions that support life. Climate change refers to long-term shifts in temperature and weather patterns, including heat waves, droughts, floods, and storms. The planetary boundary has two parameters. One, the CO2 concentration of 300 parts per million, or ppm in short, which is already well above the pre-industrial values of 280 ppm. And second, a radiative forcing of 1 watt per square meter. This second parameter includes the effects of other greenhouse gases such as methane or nitrous oxide. Introduction of novel entities such as microplastics or untested synthetic chemicals can disrupt important processes in the Earth system. Modification of biochemical flows via introduction of phosphorus and nitrogen fundamentally changes the planet's biological productivity, as they are limiting factors below 6.2 and 62 teragrams per year. These nutrient cycles interact with most other planetary boundaries as they have a central function to the planet we live on. Change in biosphere integrity refers to the capacity of ecosystems across the planets to support life. One indicator is that the human appropriation of net primary production is below 10%, or in other words, that the human use of biomass is below 10%. While the other planetary boundary states that less than 10 out of a million species go extinct per year. In summary, planetary boundaries provide a framework for understanding the planet's health. We introduced the 9 planetary boundaries and discussed how they define a safe operating space above which there is an increased risk to irreversibly damage the systems of the planet that we live on. Understanding planetary boundaries is our first step towards a sustainable future. Thank you, and I'll see you in the next session.